So I have a couple things planned for tonight. I want to start with talking a little bit about speech recognition, especially when it comes to performing that on an Android phone. Next is I will show you a brief video, then we go into a break. And then the little bit harder part begins, where we will look at more code, talking about push notification and how you can push notification actively from a server to a mobile device. And if you're not familiar now, if you stay to the very end, I will show you another short video and tell you a story about me being for 2 days in Google's garage. And that happened just 2 weeks ago. So it was a very interesting, nice story to share. But for that you have to stay all the way to the end. So, if we do speech recognition on the phone, what actually happens is we use the phone, we use the microphone in this device, we record it, and then the voice recording is sent to a remote server into Google's cloud. Google then transcribes that text for that sound file for us and delivers text back to us. So once we have that text, what do we do with it? Now we have to really prove that we quite literally understand our users. And that's tough, right? That goes into natural language understanding. Sounds like a lot of work, and that's way too difficult for us tonight. So instead I would rather show you a couple of pictures here. Digital art, that's what we call it if an essential part of the creative process, if that involves some digital technology. So look at this. Looks on my screen much better. So all these paintings I show you have been created on a phone. Think of the phone as a canvas and your finger is a paintbrush. So all done just with the phone and your finger. Beautiful stuff, wouldn't you agree? So all this was done with an application I put out 2 years ago called Artist on Android. And it's a fairly simple app. Honestly, I just wrote that app to test out what I can do with user tracking. So I wanted to figure out how good is Google Analytics on a mobile device. So I tracked all kinds of things, like how often the user changes tools, how long it takes for a user to create an artwork before he's publishing it. You can publish it, for instance, into a Flickr group, or you can share it by email, you can print it. And so just to give you a rough idea, on average, it takes the user about 20 minutes to create an image. But that's on average. The ones you saw, you probably took a little longer. The tools are pretty simple. You can see them all on the screen here. They overlay the canvas. And there's also an action bar that you can use to bring these palettes up, where you select the color. But basically, it's you select the tool, which can either be a pen, a brush, or roll. You select the style. You can blur or emboss, or blend. Blend is actually pretty cool. With blending, the tool picks up the color that's already on the canvas and blends it with the color of your tool. So there's the styles. But think about it. If you have to change tools, it's like you click on the menu, you tap on the menu comes up, and you select your tool. The menu disappears. Then you tap on the menu button again, the menu appears on the screen again, then you change your style. Menu disappears. You bring up the palette to select the color. So it's about 7 or 8 touches that you have to perform to reconfigure your tool. So and recently I added a microphone to this. With the idea, instead of doing these 7, 8 touches, you just say, give me a green blur brush. So again, I have the tools here, the styles, the colors, and the tasks you can perform. So you can say publish, or share, or print. Should be easy, right? Well, there's colors, for instance. Colors is a hard thing to name. We all say colors differently, and here I just have the blue tones. So I coded about 250 or so colors into the system. And now think about what a user can say. You can just start with the tool. You have 3 of them. You can say a color, like I said, 216. You have 4 styles. And well, you can also say like a color and a tool, a style and a tool, a color and a style. You can also reverse the order. It gives us twice the options. Or you can say all 3 things, color, style, and tool. So it creates another 6 permutations. And we add a task to it. So those, and you have to look at all these blue boxes, basically it's variables. Right? So we fill all the variables in, and it creates really a huge decision tree that you have to work through. But that's not new, really. This is very well researched and resolved using grXML. That's a standard for speech recognition grammars. And where is it used? Well, you probably all knew this. If you just call your bank or your insurance agency, what do you hear? You hear something like, hello, thank you for calling, or menu options recently have changed. And that's what we call an IVR, an interactive voice response system. And in these systems, these grXML grammars are used. Most of the time it works okay, but this does not apply to our phones, because the speech recognizer that we have on Android does not work with grXML grammars. It's a so-called free-form recognizer. So they don't care about your grammar models, they don't care about the context, they just use whatever you throw at them, and they use statistical models to figure out what was said. And here's the code that you have to write in your Android app to get your speech recognition activity working. It's rather simple, and so you call at the end start activity for result. It opens dialog showing the Google microphone, and you can configure what should be on the dialog as a title. And then the recording happens, and Google is so smart, they start sending the recording while you're still speaking. So it's all broken up. The first words are being recognized already while you're still speaking. That's why you get really fast results. So once the user stops speaking, that is obviously detected automatically. You don't have to push a button. A small pause is used for that. And then you will be called back here in this on-activity result. And you get a string array with possible results. And now your work begins. You have to now dig through text. Really, he died 2 years ago, age of 83 in Memphis, Tennessee. So Bobby Blue Blend, he is responsible for if I talk into my tool and say Blue Blend, I'm getting Blue Blend spelled with an A. Or if I say powder blue brush, I get powder blue bra most of the time. I say turquoise blur brush, and I get turquoise Blair Price, which must be a famous flip-flop that many people buy, I think. I say Scion brush, I get Diane brush. Or I say sky blue embossed pen. Google returns me sky blue in Boston, which is a female soccer team in Boston, Massachusetts. Still, typical process, how we would deal with that is, well, like I said, we use a speech recording, we record the sound file, we let the speech recognizer do its work, we get text back. Like I said, Google uses a statistical model. We still try to parse out the words as good as we can, and then we try to map these words towards actions that we have programmed, developed in our mobile app. So for instance, if you say, what's my schedule for tomorrow, you would expect that it opens a calendar app. So somewhere you have to map the schedule into the calendar. But there's more problems. It's not just the body language. There's a thing called homophones, words that are pronounced exactly the same way, have a different spelling and a totally different meaning. Or there are synophones, words that have a very similar pronunciation, but again have a totally different meaning. There is an area that is very similar, trying to deal with these problems, and that's the keypad, the soft keypad on your phone. So you have big fingers and you type, and sometimes you hit a wrong key. And so we have an algorithm called Levenstein Algorithm that helps you, or that is responsible for you seeing the very good recommendations you see underneath the keypad. And the keypad comes up with these recommendations by just having, they just look at what other words are close to that and how many permutations are necessary to convert one word into another. And that's called the Levenstein distance. And you can see it here. I carry this word Rick. So if you just mistype that, you see how many permutations are necessary to turn these words into each other. But that only works if you have the spelling of the word. For speech, that's not so good, because with speech, we start out with a word that's probably spelled differently altogether. It just sounds the same. So with speech, the Levenstein algorithm is not really well suited. But we have other algorithms that are very good for that. They call, for instance, one of them is called SoundX. And SoundX uses the phonetics. So we try to build a phonetic encoding of a string, and then we try to compare these encodings. And with that, for instance, the encoding for the word Robert and the word Rupert would be exactly the same. So if you would then compare these two encodings, they would match. Ashcraft and Ashcroft again create the same encoding. And well, to give you an idea how this works, you retain the first letter, then you drop all occurrences of vowels or letters that sound like vowels. You replace consonants with digits, and you can see the groups. All these consonants that are grouped with the same code sound about the same. Then you remove duplicates, and then you iterate through the process until you come to an encoding that again starts with the first letter and then has just numbers to it. And here you can see that that's spelled out. So Robert would be encoded with R163. So we do this, we can walk through this. So R, we just retain the first letter, then we drop the O. There's a B in there, so B matches into the code 1. We drop the E. R goes into code number 6. And then we have a T at the end, and T again goes to a 3. That's how you get to your encoding. So very simple, very straightforward. There are other algorithms, better ones. SoundX is just easier to explain, but you can find them all on an Apache project under language encoders. Most of them are language dependent. So SoundX works well for English, not so well for German, for instance. But there are algorithms for each language. The Cologne phonetic, of course, works better for German. So with that, the process would now look a little differently. We would first build a dictionary of all the words we would like to understand, so all my colors, all the tools, and then I walk through that dictionary and build the encoding for all these words. Now I capture the speech, run it through the recognizer returns me back the text. Now I use that text to encode it again, using SoundX or Untitled Algorithm, and then I just look up words that have the same encoding. And with that now I can do much better matching and launch into the activity that the user hopefully wanted me to. This only works well for little tools like my artist envelope. If you have something that is much broader, where you want to say like, I don't know, the business I'm in is all about financials, so we would say, what's the balance of my checking account? That's much more difficult, right? Because people use different words for account, as a bank account, or only account, or savings account, all kind of things. So for that, you need a little bit better tool. AIML, I talked about that a couple years back, you may remember if you were here. That's a tool that is used for bots that compete, for instance, in the Turing Test. So the Turing Test is a cool little test that they run since the year 2000 every year, where computer programs compete and they try to fool judges that the judges believe they are talking to a real human when they're in fact talking to a computer. And almost all the winning bots are built on AIML. AIML is built with domain-specific language called AIML, Artificial Intelligent Markup Language. And you can see one of these patterns here. Very simple. So the pattern would be what is star, and the answer would be I don't know what. And then we fill in what the star, the asterisk series, is. So if you would run this, and the question would be, the user would say, what is cheese? The bot would answer, I don't know what cheese is. And again, this is a very, very simple pattern. And people who compete in this Nobel Prize, the Turing Test, they commit sometimes a whole year of work to just building these knowledge bases. You can try it yourself. Pandora Bots is a web serving that hosts chatbots. It's all built, again, on AIML. And I tried that with my little tool. So I built a knowledge base where I filled in all the variables. I uploaded a list of colors and styles and tools. And it works, really. You can try this. I have an editor. You can type in whatever you believe the user would say. And then it comes back. And it's here. The human says, blue blur brush. And the result is it detects color, is blue style is blur, to this brush. So it gets that mapping right. And that's all what you need. Right? You want to map what the user's input is into things that we can understand. So that is a nice tool, Pandora Bots, an implementer of AML. There's another thing called Wit AI. They were recently acquired by Facebook. Pretty much the same idea, you just train the system differently. So with AML, again, you have the domain-specific language, where you code it in XML, you create patterns. With Wit AI, you just type in what you believe the user says. And then you mark each word. So if I say, what's the balance of my checking account? Then it would say bank account is an entity that maps into account. So you kind of build the knowledge base slowly up by defining what you think the user says. It's called like just teaching. And again, these guys have a web interface. You can then try sentences that are a little bit different from what you taught the system. And you get a JSON document back, and it works again very well. So it detects too what the style, what the color, and what the tool is. And to round it up, there's also a company, API AI. Pretty much the same. They just have a richer JSON document that gives you all kind of other things, but the idea is pretty much the same. I don't know which company currently has the edge. So, summary of that part, speech recognition, I think is readily available, and it's all up to us really to build solutions that work with speech recognition and make the user's life a little easier, especially on a mobile phone where tapping and the interaction is not really as rich as would like it to be. So we have context-free recognizers from Google, and there's new services from companies like Grid AI and API AI, and also a declarative approach with AIML. So
is Grid AI still freely available? I know
yes,
they
yes.
sold to Facebook, I believe.
Grid AI is freely available, and the model they will implement it with is the same what Facebook did with Parse. So they will probably charge you if you just consume too much of it, but an entry level will always be free. So before we go into the break, I would like to show you a little video that